Topic 13. Kinematics of rotational motion. The linear motion of an object refers to the movement of an object in a linear direction, as the name says. It depends on the speed, distance, and acceleration. A period is the time that it takes to do a turn or lap, also called a revolution. The linear speed of an object with uniform circular motion can be obtained through its period. This means, for example, that we can know the linear distance that a bike wheel did depending on its revolution. Angular acceleration is like the linear acceleration, but it measures the change of rate of the angular velocity. It differs with the linear acceleration in linear motion, since this one is related with the rotation, so they move on circles. Angular and linear acceleration are proportional, but they aren't the same. They can be obtained through each other with the ratio of the round object that is took for the acceleration. In rotational motion, the force can be clockwise or counterclockwise. In the first case, the result is negative, and in the second, positive. This due to the law that objects going to the left are negative and that to the right are positive. First exercise. A wheel is rotating and it has an angular velocity of 36 rpm in clockwise direction after 2 seconds. If it had an angular displacement of 240 radians in the same direction, calculate the angular acceleration of the wheel. We have the final velocity, which is minus 36 revolutions per minute. This is because it goes clockwise, so it's a negative quantity. The time is 3 seconds and the angular displacement is 240 radians. We transform the revolutions into radians, which gives us minus 3.76 radians per second. We use a formula to get the angular acceleration, subtracting the final velocity times the time minus the angular displacement. All of this is squared and then divided by squared time. The result is minus 54.16 radians per squared second. This is the angular acceleration. Second exercise. A turntable goes from resting to clockwise, a speed of 30 revolutions per minute in 2 seconds. If a gum is stuck on it has a linear acceleration of 2 meters per square second, calculate the distance of the gum to the axis of rotation of the turntable and how many revolutions it did in that time. We know that the initial velocity is 0, since it stated that it was rest, and the final angular velocity was 30 revolutions per minute, which is equal to minus 3.14 radians per second. The time was 2 seconds. The linear acceleration is 2 meters per square second. If we divide this quantity by the ratio, we can get the angular acceleration. We use the angular acceleration formula to subtract minus 3.14 to 0, and then divide into 2, which gives us minus 1.157. We use another formula to equal that number to 2 into the radio squared. Using some algebra, we can get the radio is equal to 1.27 meters. The radio is the distance of the gum to the axis. The result is always positive because we are talking about the measure of the ratio. A real physical object of turntable Then we transform this amount of radius into revolutions, dividing it into 2 p radians. This gave us minus 0.49 revolutions. It's negative because it goes clockwise.